be looking at how we can name alkanes according to IUPAC, which is basically the International Union of Pure and Applied Chemistry. Before we jump into naming them, let's just quickly review what alkanes are. Alkanes are organic compounds that contain carbon and hydrogen atoms with single covalent bonds. They're also saturated hydrocarbons. Alright, so when it comes to naming alkanes, a few things to note is that firstly, the formula for naming an alkane goes as so. It starts with a prefix, right? And then you add on to it the parent, and then you add on, finally, the suffix. So this is kind of the formula when it comes to naming an alkane. So we need to know this chart over here. So we're going to start with the word roots here. What are exactly word roots? These are basically what you use to name for your prefix and for your parent, which is also known as the longest chain. Okay, so you need to know this. So if it's one carbon, it's meth. If it's two carbons, it's eth. Three carbons is prop. 4 carbons is bute. 5 is pent. 6 is hex. 7 is hept. 8 is oct. 9 is non. And 10 is deca. So this is kind of important to know this, right? And something cool for alkenes is that the suffix is always ane, right? That's always going to be the suffix. Another thing to note is that from our substituents, its prefix, right? The prefix from our substituents for an alkane is YL, right? So for example, from our prefixes, it would be nano, methyl, octyl, right? And these are just for alkanes. To solidify what we've learned so far, let's work with an example over here. So we start with a fairly basic looking alkane. We have one carbon in the middle, and it's surrounded by 1, 2, 3, 4 hydrogens. All right, so let's try and name this, remember? Let's look at substituents. Are there any substituents in this case? There's no substituents. Is there a parent? Yes, it has to have a parent, and it is my carbon. This is my longest carbon chain, so that's my parent. And how many is there? That's 1. So what do we have to use here? We use meth. We have to use our word root meth. All right? Okay, so now it asks for the suffix. It's an alkane. We can use an alkane because it's single bond, so it should be methane. And that's how you can name this one over here. All right, for our second example, we've got an interesting looking one. We've got 2 carbons, all right? And it's surrounded by a total of 1, 2, 3, 4, 5, 6 hydrogens. Cool. All right, let's look at our rules again here. There's no substituents here, right? There's no substituents. We don't want to worry about that for now. There is a parent, though. There is a parent chain, of course. And how many carbons are there for my longest parent chain? The longest chain, which is my parent chain. There's 2 carbons. So let's look at our word roots here, and let's see here. Methyl or meth is 1. 2 is eth. So, okay, so my word root should be eth. Okay, found my parent. And what's my suffix for an alkane? It's ane. So it's ethane. And that's how you can name this one over here. So why don't you guys try this one on your own over here? So pause the video and try it on your own. Alright, so I hope you guys give it a try. Let's do it together now. Alright, so this, firstly, let's look here. Does it have any substituents? No, it doesn't have any substituents at all. Does it have a parent? Of course it does. We can see that there is 1, 2, 3, 4 carbons, and that's our longest chain. That's going to be our parent. Okay? And it has to have a suffix of ane, as it has single bonds between carbons and hydrogens. So therefore, this is going to be called 1, 2, 3, 4. And if we look at our word roots over here, it is bute. So it's going to be butane. Here they're giving us a line structure. Okay, so how can we name a line structure? It's the same exact steps. It's just displayed a little differently. That's all. So what I'm going to do here is I'm going to state out where my carbons are exactly. So this would be a carbon right here. It's 1. Another carbon would be here. It's 3. Another one would be here. Another one would be here. Maybe 4. Another one would be here. Another one would be here. So you kind of see a pattern where my carbons are. Something else to note about this line structure is that there's a substituent right over here. over here there's a substituent. How do I know it's a substituent? Because it's sticking out. It's sticking out on my number 3 over here. Now you may be asking, why did I count from left to right instead of right to left? Like, why is it 1, 2, 3, 4, 5, 6 instead of me counting something like this? I'm going to write it in red over here. What did I do? 1, 2, 3, 4, 5, 6, like so. But the answer to that is that I want to make sure my substituent over here has the lowest number possible, right? So we can see here, 3 is a smaller number than 4. So therefore, I should count from left to right. So in order that my substituent has the smallest number possible. Okay, let's get rid of that over there. Okay, so now let's get to naming this puppy over here. All right. So now to name it, remember the rules. It's substituent, and then parent, and the suffix. Remember, for substituents, you have to add a YL. And you also have to show where it is through a numeric value. I'll show you how it's done here. So you want to start with your substituents. And what substituent is this? It's just one carbon sticking out. It's just one singular carbon, right? That's a methyl. How do we know that? If you look at our word roots here, one carbon is meth. And remember we had an L, YL, so it'd be methyl. So I would, right over here, I would do where it's placed. So it's number 3, so it's 3-methyl. 3-methyl. And what does it look like over here? It's 1, 2, 3, 4, 5, 6. That's my parent, 6. So it'd be 3-methyl hexane. Right? And why would it be hexane? Look, it's hex. Hex is 6 carbons, and you have to add an ane as a suffix. So this is basically what it is, 3-methyl hexane. All right, so for this question, they've given it to us in the condensed structural format. As you can see here, it's just a lot more easier than writing this, right? It's just a lot more, it's less tedious, right? In a lot of questions, you'll see it like that instead of fully projected out like this, right? So if I have, for example, what I had there, I'll show you. So if I had something like this, right? This right here is the same thing as this. They're both the same thing, right? It's just one carbon and 3 hydrogens. That's all it's saying here. Okay, so let's get to doing this question over here. So here I have a alkane, as I can tell it's an alkane because single bond, single bond, single bond, single bond, single bond. Great. Okay, these don't really matter, but there's single bonds all over here. All right, so first things first, I want to identify longest chain, right? So, and you have to make sure the substituents, which I have a substituent here and a substituent here, I want to make sure my substituents get the smallest value possible, so let's get to doing that. So I go from here, it's 1, 2, 3, 4. Okay, cool. There's 4, right? But let's try going the other way. So we went from left to right. Let's try going from right to left here. So I can do 1, 2, 3, 4. Now these are both methyls, as I know it's just one singular carbon sticking out. So therefore, it doesn't really matter. They both kind of get the same value. It's 2 and 3, right? So in this case, it doesn't matter if I go from left to right or right to left. But I kind of like to keep it from left to right. All right? Okay, so let's get to naming this. The longest chain is 4. So right, if it's 4 carbons, it's bute. So we know that our ending would be butane, right? The ane, because it's an alkane, all right? And what would our substituents be? This is the little tricky part that many students may find tricky, or they might, get lost on. So I have, for number 2, if I look here, I have a methyl. So I have a methyl over here. I have a methyl. And I have another methyl over here at both 2 and 3. Some students just like to do this, right? They will do 2, 3, methyl. Now this is wrong. Why is it wrong? How many methyls are there? You have to kind of explain on how many methyls there are. So 2, 3 methyl won't work. You have to do 2, 3 dimethyl. Right? Dimethyl. Right? Now if there's 3, it'd be tri, right? So remember, it's important to put this in front of our root word here for substituents. All right? So our answer to this would be write this here. It would be, oops, it would be 2,3-dimethyl butane, like so. And this would be our answer to this question over here. All right, so what's happening over here? We got 1, 2, 3, 4. 4 carbons bonded together in what seems to be like a ring-like structure, right? So how can I name this? Firstly, let's find out our parent over here. Our parent, since there's no substituents, right? If they had something sticking out like that, oh, there would be a substituent for, right? But there's no substituent in this case, right? Let's not worry about no substituents right now. So what would our parent be? If I have 4, it would be bute, right? So we have 1, 2, 3, 4. So it would be bute, right? I know it would be bute, and remember it's an alkane, so it would be butane. Okay, I found my parent. I think I'm finished, right? Okay, no, we're not done yet. Since it's all enclosed together in a ring, this would be a cyclic alkane. So it would be cyclobutane. So to scratch out butane, it would be cyclobutane. That's what this would be. All right, so for our final question here, we have another line structure one. So first things first, I want to find the longest chain. So let's do this. So we have 1, 2, 3, 4, 5, 6, 7, 8. Interesting. So I know this is, and it's an alkane, so it's octane. This is going to be my parent. It's going to be an octane. All right. The next step would be to looking at my substituents here. So it looks like I have 1, 2. So this has to be a, if you look at the group here, our word roots here, it has to be an F, an ethyl. So this right here is an ethyl. And let's look at this one here. It's 1, 2, 3. So this one has to be a propyl. So we have a propyl here. Now, what's really important here is that if we look at it from left to right here, we have to look at our substituents in an alphabetical order, because ethyl comes before propyl, because E comes before P. So when we're writing it out over here, ethyl would come first and then propyl would come. But this wouldn't make sense, as it has a higher numeric value given to it. When we're looking at the placement over here, ethyl's 5 and propyl's 4. That's not really good. We want our ethyl to be 4 and our propyl to be 5. Let's look at how we can make that happen. So instead of counting from left to right, we want to count from right to left. So let's just redraw this and look at it again. So, right? It's a little janky, but I think it'll be fine to show what we're trying to do here. We'll count from the right side. It'll be 1, 2, 3, 4, 5, 6, 7, and 8. Okay? And my ethyl would be here. My ethyl would be right over here. And my propyl would be here. Alright? So when we're naming this, it would be like this. The correct name would be 4-ethyl. As you can see there, ethyl's on 4, so it would be 4-ethyl. 4-ethyl. And then we look at our propyl next. Now on number 5 over here, it'll be 5-propyl. Octane, which is our parent. So that's how we can name it. And this is what we're going to be using to name it right over here. This is the correct one. Alright, so that's all for this video as an introduction to naming alkanes. Hope it helped.